Today we're going to cover sections 4.1 and 4.2. So the first section, chapter 4.1, discusses water as the common solvent. So water is very important. It is essential for sustaining the reactions that keep us alive. You may not think about all the things that, not just in terms of reactions, but water is also important for cooling down the engine of our car. Water is an important source of transportation through rivers and oceans. So in addition to all the chemical reactions that take place and all the biological reactions that take place in water, there are other uses and ways that water is very important to us. Water also has another important function. It dissolves many different substances. And so we call it a universal solvent. So if you remember back to Chem 1, first year Chem, a solution is made up of a solute and a solvent. The solvent does the dissolving, and so water is a universal solvent because it can dissolve many different substances. The other important part about water is its shape. It's polar, or sorry, its shape is that it is bent or angular. And its polarity, it is polar. So I'm going to draw a picture of water, a water molecule. It is one oxygen, two hydrogens. And it's bent because of these two unshared pairs of electrons on the oxygen. And if you look up the electronegativity values on the back of your periodic table, oxygen has a higher electronegativity value compared to hydrogen. And so the electrons are more closely pulled towards oxygen than hydrogen. And so we have a partial negative charge on the oxygen and a partial positive on each of the hydrogens. And so a dipole forms in both directions. Since they're at an angle, they don't cancel out, and so that's why it's polar. And this polarity of water gives water its great ability to dissolve compounds. So what we want to look at next is hydration. And so figure 4.2 does a good job of illustrating hydration. And so here are our water molecules here. And then you have your ionic compound in the green and gray, that crystal lattice structure. And so when hydration takes place, the partial positive ends of water molecules are attracted to negatively charged ions. So if you look up here on our diagram, you can see over here, this is our negatively charged particle, and the positively charged partial positive hydrogens right there are attracted to the negatively charged ions, the anions. And then the partial negative ends of water are attracted to positively charged ions. So up here, this example right here, you have oxygen, which is negatively charged, attracted to the positively charged anion, the cation. And so when you have hydration, if you look at this figure, what's happening is the water's coming in and it causes the salt, the ionic compound, to dissolve in water. It's basically taking apart the crystal lattice of the ionic compound. So hydration So I'm going to draw an example or write out an example hydration equation. So here's my example. I have ammonium nitrate, solid. It's put in water. The water molecules hydrate that ionic compound, the ammonium nitrate, and it forms ammonium cations that are in solution. The aqueous means they're dissolved. And the nitrate anions in solution. And so if you don't remember, this stands for aqueous. So the solid is put in water, you stir it, and the ammonium ions separate from the crystal lattice because of the partial negative charge on the oxygen. The nitrate ions separate from the crystal lattice due to the partial charge of the partial positive on the hydrogen of a water molecule. And please remember, if I go too fast, you can always pause the video and then restart. Solubility. So solubility varies greatly for ionic substances in water. For example, ethanol is very soluble in water. Due to that polar OH bond. I don't need that little dot there. Water does not dissolve nonpolar substances. So fats will not dissolve in water. So I always like the saying like dissolves like. So polar solvents dissolve polar or ionic solutes, because like dissolves like. Nonpolar solvents dissolve nonpolar solutes. What we're going to do next is move on to chapter 4.2, and this covers strong and weak electrolytes. And so first we need to define electrical conductivity. And so electrical conductivity is the ability to conduct an electric current. So how do we test the conductivity of a solution? Well, we use a conductivity tester. In your book, there's figure 4.4. It shows a conductivity tester, and there are 3 light bulbs. You can see on the left, we have a strong conductor. See if it labels them underneath. So we have a strong electrolyte. And there are 3 classes of strong electrolytes we'll talk about. But when you look at the solution, you will see that it's completely ionized when dissolved in water. So you just have ions in solution. In the middle, we have a weak electrolyte. Which means there's few ions in solution. And then we have non-electrolytes, which means it does not form ions in solution. So we're going to look at examples of all 3. So the first one we'll look at are strong electrolytes. And strong electrolytes completely ionize when they're dissolved in water. And there are 3 classes of strong electrolytes. So the first class is soluble salts. And figure 4.5 in your book shows a soluble salt. It shows sodium chloride. So on the left hand, you have your crystal lattice. And then add water, it dissolves and you form ions in solution. So you have positive ions in solution, you have negative ions in solution, and those ions conduct electricity. So if you were to write the equation, sodium chloride in water completely forms sodium cations in solution plus chloride anions in solution. And it completely ionizes in water, which means those ions are in solution and they conduct electricity. The second class of strong electrolytes is, give myself some room right here. The second class is strong acids. And so we will have a whole chapter. I think there's actually 2 chapters we'll cover in terms of acids, but we are going to cover a little bit here about strong acids in terms of how they are a strong electrolyte. So acids are a substance that produces hydrogen ions, a proton, when dissolved in water. So when hydrochloric acid, nitric acid, and sulfuric acid, these are just 3 of 7 strong acids I'm going to use today, are placed in water, virtually every molecule ionizes, forms ions in solution. And so figure 4.6 shows us hydrochloric acid in solution. I'm going to write the equation. So hydrochloric acid in solution completely ionizes. And so here's our example for strong acid. Hydrochloric acid, which is aqueous, in water will form hydronium ions plus chloride anions. What happens is this hydrogen here goes to the water and you form hydronium ions, H3O plus, and chloride anions. The third type of strong electrolyte is a strong base, the third class. So a strong base is a soluble ionic compound containing hydroxide ions. So the example I'm going to use is a group 1 metal hydroxide, sodium hydroxide. So sodium hydroxide, and you'll see this in figure 4.7, when it goes in water, it completely ionizes, forming sodium cations and hydroxide anions. So we've looked at the three classes of strong electrolytes. What I want to do now is talk about weak electrolytes. So in that diagram we looked at, these would be the ones where the light was dim, the middle one. So they don't conduct electricity as strongly. These are substances exhibit a small degree of ionization. So they produce few ions when dissolved in water. And so the most common weak electrolytes are weak acids and weak bases. So in this diagram, figure 4.8 is, I'm using acetic acid, which is in vinegar, as our example. And I'm using this as an example of a weak acid. So if you look at our diagram here, you only have a few ions in solution. So if I write this equation, acetic acid plus water, and this reaction does not completely form, so we have a double arrow, so it can go forward or reverse, produces hydronium ions in solution, and it produces acetate ions in solution, but it's not complete. It's only a slight ionization. So in this, in a beaker, you would have, or a solution, you would have, if you looked at it, you would have hydronium ions, you would have acetate ions, you would have water molecules, and you would have acetic molecules, because you have the reaction forming ions and then the ions going back and forming acetic acid and water. So this dissociates or ionizes only to a slight extent. So since there's fewer ions in solution, then you don't have as much conductivity. You don't have the light doesn't turn on as brightly as if you had a strong electrolyte. Weak bases are the other example of a weak electrolyte. And so very few ions are formed in solution. So the example I'm going to give is ammonia. And this is a weak base. So if you look at figure 4.9, you can see you have all these ammonia molecules and you just have a few of the ions. So if we write this equation, again, this goes in the forward direction and the reversible direction. And what happens is you have hydrogen from water donates a hydrogen ion forming ammonium and hydroxide ions. Again, there are a few ions in solution, so it does not conduct electricity very well. And the last thing we have to look at are non-electrolytes. This is the last beaker in our figure at the top. They dissolve in water, but they don't produce any ions. And the best example of a non-electrolyte I can give you is sucrose, sugar, any kind of sugar, glucose, fructose. So sucrose is C12H22O11. And you can dissolve sugar in water. You may remember doing that in first year chem with the physical and chemical changes activity. One of them was to dissolve dissolve sugar in water, and you figured out how to dissolve it faster, stirring it, breaking it up. And so in water, you don't have ions, you still have the sugar molecule. Water surrounds it, it does dissolve, but it doesn't form ions. So that's why the light bulb of our conductivity tester does not light up. So make sure that you take a picture of your notes and insert them into the assigned Google Doc. I will take any questions when you return to class next week, and then we will do another part of section 4 together. If you have any questions before then, just send me a message in Schoology.